It's not like kalau dalam Word you just insert picture, right? So dalam LaTeX you write a coding to insert the picture and that picture in this PostScript format. And the output of LaTeX ni you type is like you do programming, you type, and then when you run, you simulate, keluar the output, and the output is in the form of report, PDF report. Okay, so there are two ways lah yang you learn. Straightforward, pakai Word je lah, senang. This one you have to learn the programming. Okay, so PDF. Okay, PDF, portable document format, is a file format used to represent documents in a manner independent of application software and operating systems. Each PDF file encapsulates a complete description of fixed layout flat document, including the text, fonts, graphics and other information needed to display it. So that's why kalau you hantar report, any subjects ke, not just in university ke apa-apa ke, report industry ke, when you submit report, submit in form of PDF. Why? Because PDF ni, tapi sekarang dah senang nak edit kan. Dulu PDF, setting tak lari. Sometimes when you like, for example, you type your report guna Word in your computer. When you send to other people, if they are using different format, different version, sometimes most of the time selalu jadi the type setting tu lari and page lari, semua lari. But that's why you need to convert to PDF. So bila you PDF, dia ada fixed layout document. So dia tak boleh nak tukar. Okay, so that's why we use PDF. Okay, so tadi kita dah tengok color depth, kita dah tengok format. Okay, and then dia ada color science. Okay, color science, color is an essential element of multimedia. So color ni ada kat semua benda. Okay, effect of color is very important in multimedia. Graphics, bitmap images, video, animation and text. Semua ni you can play with the color. So we can say that it is an essential element of the multimedia. And color science, sorry spelling error here. Color science attempts to relate at the subjective sensation of color to measurable and reproducible physical phenomena. So the simpler word is color ni could play different sensation to different people. So that's why some people they suka color striking colors, but some other people may like softer color. So this one semua dia very subjective sensation on how you choose your color. Apa dia? Dia I think, let me see I think when I put in blue button dia lari sikit the setting ni. So that's why when this is another effect. When I in blue button there's mention recommended to upload PDF to make sure dia tak lari lah. So yang ni dia macam banyak tertinggal kat bawah ni. So never mind, nanti when I upload in Putra Blast, you can get the betul lah it's okay, should be okay. So a spectral distribution is a description of how the intensity of light varies with its length. So let me see kejap ada ke? You cannot see my screen, right? Sekarang you nampak screen blue button je. So you can see all my screen.
Nampak color sign.
Apa?
Nampak color signs lagi.
Nampak color signs lagi okay. So dia tak lari lah. Sekejap ya. Betul lah. So the note should be okay yang I upload later, will upload later. Okay. Spectral distribution ni, yang last kali tu yang ayat tertinggal tu, it is a good model of color tapi complicated to work with dalam computer graphic. Okay, so nanti should be okay. Okay, so this one RGB color. Kenapa jadi besar? Kalau saya kecilkan dia jadi kecil ke? So cuba tengok lagi. Oops. Kejap tak boleh kecilkan. Fit to pitch. Okay. Kejap Okay. So this one dia nampak semua. Kalau saya buat full screen, dia tak nampak. So any color is specified as 3 values. Tapi tak itulah pula. So this is 3 primary colors, red, green and blue. Okay, RGB. Often written as 6-digit hexadecimal number with RGMB. Dia full line. Okay. RGB is between 0 and 255, so a color value occupies 24 bit. Okay, so dia okay. So this one pun daripada subjek sains kita dah belajar color combination from this RGB. Kita akan dapat either additive color or subtractive color. So we know we have this one. Additive, magenta, cyan dengan magenta, kita dapat balik ni lah. So this is a combination of color. So additive and subtractive. So apa ke namanya? Ni kita add, dapat ni, kita add, dapat ni, kita add, dapat ni. So yang A ni on the left, specify additive color. And cyan, magenta, yellow is used to specify subtractive color. Okay. Okay, RGB to SCMY. That is apa? Ini melibatkan vector lah. How to do it? Transformation RGB to cyan and the inverse transform. Kita balikkan dia. Okay. Okay, the application. Typical RGB input device, color TV, video cameras, image scanners and digital cameras. And this is input device. Output device, TV sets of various technologies. So sama ada TV pun ada banyak jenis. Ada CRT, LCD, plasma, computer, mobile phone displays. So mobile phone displays tu dia punya output. Video projectors, multicolor LED displays and large screens such as Jumbotron. Color printers, they are not RGB based. Color printer dia pakai color printers. Color printers dia pakai subtractive color devices. Okay. So I think after this now dah tahu ni, I think I need to convert all this apa namanya? I have to convert to PDF so that you can have a full view of the sentence ni. Okay. YUV, okay, dia ada banyak sistem. YUV, kalau you pernah tengok, different country they use different color encoding system. This is for just for your knowledge. Maybe you don't know dah tak merasa pengalaman ni. This is for analog television. Kita ada NTNC, National Television System Committee, and juga PAL, Phase Alternating Line. So the human closing standard used in is dia ada selalu ada, usually we use TV, you use RGB model, but there are also other color model. Okay, this one is standard. Computer graphic dia memang pakai RGB, but there are another color model called as YUV. YUV, this model they look into three effect ni lah. Y, luminance, and then UMV ada chrominance component. So dia ada masukkan elemen brightness dalam dia punya color model. For RGB dia memang masukkan color sahaja. That 3 primary colors. So then this is just mathematic how dia buat, dia relatekan dengan UV dengan RGB. Okay. But I will not explain in detail here. Okay. Okay, so panjang pula dia punya ni. I think saya ada slide yang tertinggal ni sebenarnya because I should explain about NTNC and PAL semua. Anyway, YUV, decomposite of color image. Okay. So bila you apply YUV ni ada chrominance, ada dengan brightness. So this is the original color image and this is Y transform. And B, C and D are U and V, the chrominance. Okay, this is when you use that YUV color model. Dia ada juga guna YIQ. YIQ used in the NTSC color TV broadcasting. So I will not explain again. This is just for your knowledge about YUV. We use standard color model is RGB, but there are other model used by this one for analog broadcasting. YUV, YIQ. Okay. Okay, YIQ. So this is YIQ punya effect. I think I know why. Okay, this is YCBCR. Okay, this is all another type of color model. Okay. So, and kejap ya. Wait. Kejap. Okay. So dalam, we look into the RGB color model. Dia ada tengok dia punya in terms of lightness and brightness given by these two, HSL and HSV. Okay. So this one, the difference dia punya lightness lah. And then we rearrange the so that we either use this to get better representation. And these two are used today in color pickers in image editing software. You can use this in image editing software, nanti you can see this effect. Dia punya in terms of pure white ke dalam HSL tu, brightness dalam HSV. Okay, and less commonly in image analysis and computer vision. So the HSL stands for hue, saturation and lightness. HSV stands for hue, saturation and value. So the difference, ni tengok lightness, ni tengok dia punya value intensity. Okay. And then dia ada juga HSI, silap saya dah ni. Dia tengok on intensity. HSV value or HSL lightness takes the shape of a cone or bicone. This called hexagon model, while HSL is of course a bi-hexagon model. Okay. So dia ada, kalau kita tengok daripada plot ni, lightness, hue, dia punya angle tu, hue, saturation, and this is the lightness. And the difference antara, this is HSL, this is HFV. So both are cylindrical geometries dan berbeza dia punya hue, start dengan dia punya, kalau you tengok the color in terms of the color tu dia very light kat area HSL. And this is value, dia punya color tu lagi terang. So HSL dia more on pure white on lightness. Okay. And starting at the red primary at zeros, passing through the green primary and the blue primary at 200 and then wrapping back at 360. Dia ada cylinder, dia complete 360 degrees. Cuma bezanya tu lah. Yang HSL dia on pure white, on lightness, value dia more colourful. Okay. And then this is color model yang tadi tu lah. Kita ada cone dengan bicone tadi tu. Okay. If we plot hue and lightness and value against chroma rather than saturation, you akan nampak resulting solid bicone or cone. Bicone dia cone satu je. Bicone dia dua-dua atas bawah. Okay, respectively not a cylinder. And such diagrams often claim to represent HSL or HSV directly with the chroma direction label as saturation. So ni dia tengok dia ada satu faktor tak ada, tak masuk. S tak ada, saturation. So we plot over chroma, we will get this cone shape. Okay, the next one, okay, the next terms dalam image that we selalu do, always do is called as dithering. Dithering is a technique we want to create illusion of color depth in images with a limited color palette. For example, your system dia ada limited color palette, we can do dithering. So in a dithed image, colors that are not available in the palette are approximated by a diffusion. You diffuse colored pixel from within the available palette. Okay, so this is example of dithering. Okay, for example, you only have red and blue. The only colors used, but as the red and blue squares are made smaller, the patch appears purple. So I think sekarang kan ada banyak kadang-kadang we dapat message ke email ke into how the optic tu, the something that you can image your apa dia panggil optic illusion, something like that lah. Asalnya this one is just these two colors, but if you do dithering, you can see seems like the color is purple. So this is how you want to explain the effect of dithering. And dithering in any editing software, so selalunya dia ada built-in dalam tu, and then dia ada different algorithms of dithering, random, average, ordered ataupun Floyd-Steinberg. So what is, okay, so random, okay. The first one is random dither, generate a random number for each pixel. So dia buat random dither tu, if greater than number pixel, you set as white, otherwise it's black. So but for this algorithm random dither, you will get a crude and noisy image and almost never used by anybody pun random dither. So I think there's another example. So this is example of random dither. So dia ada calculation yang ni lah. So yang if greater than certain pixel, you set to white, otherwise it's black. So there are some places black, some so based on that algorithm. And average dither. So this one you calculate from the pixel value, you calculate the average value. Is each pixel is above this, then white as black. Crude and contrast also almost never used, but better quality, okay, for average dither. Okay, and then this is ordered dither. Ordered dither divide the image into ordered cell or matrices, and then dia akan matrix cell, dia ada average threshold. So generate a block of pixel to represent each cell, and this method ordered dither widely used by the printing industry but not in multimedia. So this is in ordered dither. Floyd-Steinberg data. So this one widely used in multimedia. Okay. Kalau you tengok sini dia ada diffuse let's see the difference between this and the original pixel is the error for that pixel, and that error diffuse over adjacent pixel that have not yet been processed, and when this process the error is added to the new calculated color. Okay. Sekejap So this is example of a Floyd-Steinberg data. Okay. This one, I hope you can see this kat your screen. We focus on this kat tengah-tengah ni. Okay, this one is smooth. Original image using the WebSafe color palette with no dithering applied. Note that the large flat errors and loss of detail. And then kita masukkan. So this one, katakan you ada some processing using online editing software without Floyd-Steinberg dithering. So this one you nak tambah, you want to edit, you want to add the dithering effect to the image, right? So this one no dithering, and this one that software use Floyd-Steinberg dithering technique. Okay, same palette is used. The application of dithering gives a better representations of the original. So we can see that between here and here. This one kita apply dithering. Of course the original picture tu lagi bagus and then you just want to edit your picture. How dithering could give a better representation of the signal. So that's all. So for this one, okay, this chapter not finished yet. There is another part. This is a quite long chapter because this one yang kita belajar ni just the basic terms dulu. And for the next part, I think it's more on the acquisition. So what we cover today, okay, kita tengok format, kita tengok color depth, kita tengok color model. Okay, I think let me start here. So I hope you are still with me. Okay, can you share with me apa topik yang subtopik yang kita belajar today? Macam mana nak type ni? Okay. Okay, the first one what we look is to about image is what is color depth, and then the second one is color format, formats, image format ada banyak. Okay, so we have this is the extension file. I hope you understand. .jpeg, .png, apa lagi?
GIF.
Apa?
GIF.
GIF. Sorry.
XPS.
.ps. .ps and then kita ada .bmp. So that is all the color format. Okay, alamak macam mana saya nak panjangkan ni? Okay. Okay, summary from image part 1. So the first one is color depth just now. And then you should know format, image format. What else? Apa lagi yang saya sebut kalau you boleh ingat apa saya cakap if you listen to me. I hope you
Dithering.
apa?
Dithering.
Okay, dithering is the one of the processing technique. Image processing technique. Okay, what type of compression?
Lossless. No compression.
So this is a compression technique. Ada dua kan? Satu lossy versus lossless. Okay. Apa lagi yang saya sebut? Color model. So what are the color models? The common one is color models. Huh?
RBG.
RGB. Color models yang paling basic RGB. Lepas tu kita ada Y, U, V. Okay. And then lagi YIV. Lepas tu, and then RGB ni pun dia ada dua kan? Ada dua, HSL ataupun HSV. Mainly use either HSL atau HSV dan dia ada jugalah HSI. So and then this is what I want to highlight dalam ni lah, all about images. Okay. So nanti next week kita ada, I'll try to continue that means masa week 7 tu, ni sekarang, pukul berapa dah sekarang Oh, I think I can continue, baru pukul 10. I think I can continue chapter berapa? Part 2. Part 2. Kita sambung sikit boleh lah hari ke? Ke semua sleepy? All are very quiet. So ada 60 orang. Okay, we take a break and then I continue image part 2. Okay, because next week ada tu kan. Kita ada test, so there will be no class because on week 7 tu saya nak on text. So kita sambung sikit boleh Syafiq kata okay, boleh
Boleh.
boleh. Okay, so we will continue image part 2. Let me see. Is Azizul Haq here? We have 60 students. I don't see Azizul Haq. Mazin ada. Mazin, you are here So before okay, so just want to repeat back. Mana announcement? Okay, this one. Just want to repeat back. So
Doctor,
this
I'm here.
apa?
Azizul, you call me right, doctor?
Oh yes, okay, you are here Azizul So I think you came in late just now. So for your lab, this one, I just want to highlight this again. Lab report submission. So far, this is the report that I have received for lab 1. 32 students, 28. Full marks. If you submit on time, full marks is 10. Or you may get lower, but if you submit late for all your reports, full mark is 7. So deduct 3 marks because of late submission. And for lab session
Yes,
link, it will be provided by the demonstrator. She already emailed for link for today and this Friday. And we will have this online lab session until week 7 only. And next week we will have our test. Somebody want to say anything?
okay. Doctor, I
Okay.
want to say, doctor, me and Mazin Hamza actually don't receive the lab time, the email you're talking about. That one we don't receive. That's why I contacted you through the email.
Because are you sure you enter? Wait, let me see. Okay, lab
Yes,
session
doctor,
link.
I checked it again and again. I just checked it again and again. Everything is there, is accurate.
Because she sent based on the email that you shared in the Google Sheet. So that is her list that she has. But anyway, for this week, I already shared the link in Putra Blast. For
Okay,
this
doctor,
week.
I think it's better because only
Okay.
me and Mazin Hamza, I think you don't receive the link. It's maybe because we put the email number a little bit late.
Most probably, but maybe. Okay. Okay, so our test next week during class, you just log into Putra Blast and you will be, you get the instruction there. And topic until today's lecture, Levin Raj. Levin Raj, I want to know about Tarmes. Can you contact him? because I think he hasn't joined my class yet from the beginning until this week, and I received I heard from other classes, other lectures, also the same. Tarmes always missing in action. So can you please inform him? Tarmes, are you here or he's here? I don't think I see his name. About the test, about the lecture, about the lab, because if you don't submit your report, if you don't attend the test, then you'll be in trouble. Okay. Is he in college now, Levin Raj? Okay, please inform Dharmesh to about the lab, about everything. Eh? Okay, so I think I want to continue a bit on image part 2. Okay, so please inform Tarmes about the test and everything. So I hope everybody will come for the test. I don't like